Hello everyone and welcome back to the channel. In the last two videos, we learned how to run the PDB to GMX command and how to make the necessary edits in the receptor and ligand .grow and topology files. Today we are moving one step further. We will define the unit cell and fill it with water molecules. So let's dive right in. Let us first define the box. You can use this particular form, define box.grow. First, let's move on to the tab define box, as I have shown you over here, by simply clicking on the tab as such. So the form that appears, this form of software is designed to create the unit cell for simulation. Now here's what you will see. This tab contains a single section that actually runs the edit conf command in the background. Its main purpose, to create a virtual box around your protein ligand complex that we have created in our previous step. Now let's get the options straight. You will need to select the grow file that you edited in the previous step. You can do it using this browse button, and we have edited this conf.grow file in our previous step. Therefore we will select it and hit this open button. This distance d parameter defines how far the box extends from your molecule. By default, it's 1 nanometer, which usually works well. If you wish, you can increase or decrease the size as per your requirement. Then there's this box type -bt drop down, as you can see over here. This drop down allows you to choose from various box shapes that are available and offered in GROMACS. Well, say for example, you can select the box type triclinic, cubic, dodecahedron, octahedron, but for time being and for simplicity, let us stick on to the default triclinic box type. And here let's go with the triclinic box type. Now this is how you run the command. Once you have set up everything right, all you need to do is to hit this run edit conf or hit run edit conf button. So once you hit this button, behind the scenes, this action executes the gmx command, as you can see over here, gmx edit conf with -f option that takes conf.grow as an input, then -d option that takes the value 1.0, box type triclinic, and name of the output is supposed to be box.grow. So that's it. You have now created the virtual box around your protein ligand complex. Make sure to keep an eye on the output console on the right hand side, as I am showing you over here. And whenever you run or execute any GROMACS command in this software, if you see the message like GROMACS reminds you and something, this means that your step has completed successfully. And that's how you define your simulation box. Next, now let's fill this box with water molecule. But before that, if you are still watching, it probably means that you are enjoying this tutorial. So don't forget to like this video, subscribe to my channel, and hit that notification bell so you don't miss what's coming up next. Well, now let us move on to solvation procedure. All right. Now to proceed for solvation, just click on this solvation tab. This tab is designed for the solvation process, which means it populates the simulation box you just created with water molecules around the protein ligand complex. So this tab is also a simple one. It has a single section where you can select the grow file using this browse button. You can select the topology file using this browse button from topology file selection, and optionally, if you are interested, you can also rename the name of the output file. Well, now let me show you how is that you run this solvation command. All you need to do is to follow these simple steps. In the very first step, in this structure file dot grow section, what you need to do is to go to this browse and select the box.grow file that you have recently created and hit on this open button to load the box.grow file into the software. Next step, you need to select the topology file. You can select it using this field topology file.top. Use the corresponding browse button and select the topol.top file that is there in your working directory. And the third thing, let us keep the solvated.grow as the default output name. Once everything is set up, you are supposed to run, or you are supposed to hit this run solvation button. So hitting this run solvation button executes the gmx solvate command. As you can see over here, this is the command that was executed in the background, like gmx solvate with cp option taking box.grow as input, cs option specifying the spc216.grow. we have hard coded this option. Then dash p will take the topol.top as an input, and it will create an output with the file name solvated.grow. And just like that, my friends, your protein ligand complex is now surrounded by water molecule. In this case, as you can see, the topology file will be automatically updated to include the water molecules, and your system is now ready for the next step in the simulation process. Well, no new files are created here, only the topology file got updated. Well, now let us visualize how exactly your box solvated.grow file looks like. So you can open VMD. In VMD, you can efficiently visualize whatever you have created. Let us load this box.grow file, which is located on my desktop. It must be somewhere over here. Let me load the box.grow file that the solvated.grow file that we have simply generated. Just click this open, and you can see by hitting this load button, this is how your solvated protein ligand complex looks like, that you have recently generated using the solvation utility from the GrowMax GUI. Well, so that's how you define your simulation box and add water in GrowMax using this interface. In the next video, we will move on ahead to adding ions and perform energy minimization. If you found this helpful, drop a like, leave a comment, and don't forget to subscribe for more tutorials like this. Thank you for watching. See you in the next one.